It is a very good habit trying to connect similar topics from different subjects, and it is also okay to get confused in doing so. But it is not wise not to clear your confusion. The question paper setters have good idea of these confusion zones where there are high chances for students to commit silly mistakes even if the question is very simple. Let's take a very simple question as an example. Try to solve it yourself within 30 seconds. Remember that more than one option can be correct. The answer is only the option A. If you have selected option C and D, then you are quite stupid. But if you have selected option V, then you are just little confused. In mathematics, we know the graph of a linear function is of the form y is equal to mx plus c. If the question has considered linear function instead of linear device, then this question was purely of mathematics and both options A and B would be correct. But the term used in the question is linear device, making this question of physics. In physics, the graph of linear device is composed of particularly Ohm's law, which states potential across a device or element is directly proportional to the current flowing through it, and the constant of proportionality is referred as resistance. Comparing this equation with general form of linear functions, we can observe there is no constant in this equation. It is only y is equal to mx. Therefore, the graph of linear devices are straight lines which must pass through the origin. That's why only the option A is correct in our case. I hope this confusion area is clear to you all. The difference of just one word in the question will change the answer. Whatever we have studied right now is actually of network theory. Now we will clear our understanding with respect to linear time invariant systems and differential equation. Linear differential equations you will study in mathematics. Linear devices are considered in many subjects like signal systems, network theory, and control systems. And the objective of this lecture is to make you confident in determining whether the provided differential equation of the system is of linear time invariant system or not. There is a slight difference when we deal with differential equations in different subjects. When we deal with differential equations in mathematics, generally y, which is the output, is the dependent variable, whereas x, which is the input, is the independent variable. However, in other subjects like signals and systems and control systems, both output y and input x are dependent variable which are dependent on and the variable which is time in most of the cases but can be any other variable also. Here we have the general form of a differential equation where an minus 1, etc. are the coefficients of the output yt and its derivatives, whereas bm, bm minus 1 and so on are the coefficients of input xt and its derivatives. C is a separate term not consisting of output or input. There are rules which a differential equation has to follow for the equation to be a linear equation. First rule is the dependent output variable and its derivative must appear linearly. Even their products are not allowed at all. The same goes for the input dependent variable xt. The third rule is no function of dependent input or the dependent output variable are allowed for any coefficient. The constant c is not allowed at all. Well, these are the rules for linearity of a differential equation. Now we will see the rules which are to be followed by a differential equation to be time invariant. The first rule is any of the coefficient cannot be the function of independent variable t. The separate term c is allowed only as a constant. We have seen the rules for linearity and time invariance separately. Now we will merge both the rules to find the rules which have to be followed by the differential equations for the equation to be representing a linear time invariant system. First of all, it is very clear that C is not allowed at all. We will remove it completely from everywhere. The third rule of linearity and the first rule of time invariance, if we merge these 2 points, then we can observe that the coefficients are neither the functions of input variable, neither they are the functions of output variable, and also they can't be the functions of independent variable t. Therefore, the coefficients are allowed to be constants only. After modification, we get these rules, and even the standard form of the differential equation is also modified. We have removed the constant term and also modified the rules for differential equation. In-depth knowledge is actually very important if you have to prepare for subjective exams as well as for any interview. Remember that there are only 2 approaches to prove that the given equation is not of a LTI system. Either it is not linear or it is not time invariant. If the differential equation is both linear as well as time invariant, the system represented by the differential equation is a LTI system. Now suppose in an interview an equation is provided to you and you are asked to tell whether the provided differential equation is representing linear time invariant system or not, and you see the equation is also having a constant term c, then you can recall quite easily that this is not an LTI system. But what if the examiner asks you to prove it? You will be able to prove that only when you remember that you have to proceed for nonlinearity. If you are trying to prove this equation to be time variant, then you will simply waste your time. This in-depth analysis will be very helpful for you in interviews and subjective questions.